So I had a conversation once where I was asked, why don't more people try this stuff out? And I assert that more people would try out both OpenFlow in particular and SDN in general if it spoke the standard protocols. And this was an actual Q&A. Why don't people use this stuff more? And my answer was, because it doesn't speak the standard protocols. And this realization led to some work that we're doing. I call it a research project here, but it's, the goal isn't papers. It's we want to build stuff and put it out there that works in order to foster innovation in this space. As kind of an unachievable goal, we set for ourselves that we were going to build an open source LSR with some SDN inside. And so there's a little note at the bottom. I'm not really talking about Google production or anything, just so you know. So what does collide mean? IP and Ethernet are great, but in the service provider space, there are these other protocols that we use, things like IPv6 and MPLS. We use ISIS and generally not OSPF. We depend on the traffic engineering extensions to IGPs to run things like RSVPTE to manage capacity and utilization on our networks. We speak BGP. Don't get me wrong, I like OSPF, I like it just fine. But when we get a new box or new network, and we've talked about this a little bit in this already, the first touching of the new box is with a really, really, really high policy fence. Right? BGP is really good for ensuring that whatever smoke and flames happen on the other side of the policy fence, it's not going to mess with my network that I know works already. And so typically we stand up a new network on the other side of the really tall policy fence, and then when it doesn't burst into flames, when it doesn't crash and burn and take everything down with it, then we let it into the IGP, right? Then we trust a little more to be able to exert less policy influence over it and pass packets through it as a network. When we really start to trust it, right, we've kicked the tires on the TE extensions and we get a good feeling that the truth of interface utilization is actually being flooded in TE LSAs. Then we'll use our CPTE to actually place LSPs over that. That sort of thing. This is the incremental deployment roadmap, right? And this is what we do. We don't generally go all in. So tools to make it possible to do this incremental deployment are really helpful. Now, we've talked about this, right? I'm not going to belabor this slide, but what SDN provides me is the ability to manage ephemeral information ephemerally. There's a whole bunch of state on a network element that if I reboot, I don't care if the state comes back. I can put it there dynamically. So being able to program my device rather than configure it. I really like to manage my resources centrally rather than some of these distributed applications that use this this imperfect knowledge of things like what was utilization on a link at the time when a TE-LSA was created and flooded through the network. Well, by the time someone gets around to acting on that, the network has probably changed, and independent competing decision makers probably aren't going to optimize as well as a centralized application that has knowledge of global state. Then last, within the context of my existing network, I want to be able to decide whether I'm going to add new services inside that network or next to that network. So, I'm going to talk a little bit about building this open source LSR. We did it last year on NetFPGA, partly because it was fun, partly because there was no commercial silicon to which we had access that would forward MPLS packets. Everyone burns their the formats that they understand. They're burned into the ASICs, and there's no slot where I can put some extra coins in to say no. I want you to on the LSA or on the MPLS ether type. I want you to do a label swap. Right. So we dug up the MPLS Linux port. We used Quagga LDP to distribute labels. We built some custom firmware for the NetFPGA to do label swapping, And with a little bit of glue, we actually put together and demonstrated at Nanog 50 a working open source LSR based on this stuff. So that's nice, but we really do want to use things that are a little easier to work with. So this year comes along the opportunity to build something that could be, candidate technology to use inside a network like these guys are building, where we take the Quagga IP stack with its, the standard protocols, right? IP, Ethernet, BGP, SPF, ISIS, and with some route flow glue from the CPQD folks, and some Knox OVS flavored SDN. Right, you can go buy a Pronto 3290, and it comes with an OpenFlow 1.0 implementation. We could build a working internet router with SDN inside that these guys can then take and decide, does their OSSE, how do you say that? OS3, sorry. So, do you put your OS3E stuff on the side of the routed network? Do you work to, enable services within the routed network? Right? Is the routed network an application that the controller manages with alongside of other applications? These are questions that, as we talk about hybrid switches and service models, we can build real things to try them out and see what solutions work for what types of applications. In our little project, next up we're working on ISIS-TE extensions. We're working on RSVP-TE and getting LDP, those working with a userland LFIB so that we can sit on a kernel that doesn't have a label table itself. We want to glue that label. We want to glue the LFIB in userland down to hardware that supports things like label swapping, push pop, to get MPLS working. We're obviously we're tracking the development of the standard of OpenFlow to be able to control a device that that has tables like this, that that has multi-table support. Very much looking forward to IPv6, and to the example that I was just referencing, right? Exposing the controller that the routed network sits on top of to be able to provision services next to it. More stuff, right? We've got to, in order to build a working internet router, we've got to pull counters out of the hardware using whatever mechanisms are available, and we've got to ensure that those counters are flooded through T extensions to IGPs to make sure that things like MPLS auto bandwidth work. We can write MPLS auto bandwidth. Now this is so far it's been I've been talking about building a router. Routers are nice, but there's also been some conversation about support and ecosystem, and we are keenly interested in actually building an ecosystem here. So while we're doing the system testing level, we've certainly learned a lot about things like flow expiry, about how SDN handles things like IP fragments, how SDN implementations act differently when they're talking to virtualized switches versus real hardware. But we've also, in order to create this ecosystem, we want to create a support channel for folks. When these guys have a problem, they want to call somebody, and they're going to call Bill. Bill's waiting to stand up and wave at all the nice people. So Bill is with the Open Source Routing Forum, and they are chartered to do this kind of support, right, in an open source world. And at the end of all of my talks, I always like to plug RFC 2702. It's an oldie, but still an excellent read if you're wanting to talk about the vision that we've had for software-defined networking. We've actually had this vision for a long time, and it's really nice to see it coming to fruition.